Alright, today we're going to solve trig identities. So we're striving to prove that this side right here is equivalent to this side. So in order to do that, we choose the most complicated side, which is this one, since it has parentheses and it's subtraction. So in order to do that, our first step is to expand this. Since it's squared, it's this quantity times this quantity. So right here, we have expanded that. So now we're going to begin foiling. It's going to be sine times cosine, which gives you sine squared of x. Then we do sine times negative cosine, which gives you negative sine of x times cosine of x. And then we do negative cosine times sine, which gives you another negative sine of x times cosine. And then we do the outside terms, the negative cosine of x times negative cosine of x. That gives you positive cosine squared of x. Then we look to see if we have any like terms. And we do. These two terms are both negative, and they're both sine of x times cosine of x. So then these can reduce to 2 times sine of x times cosine of x. And this is all over cosine because it's being divided. So right here, we begin to rearrange by moving this to the front. And since sine squared of x plus cosine squared of x is equivalent to this, and this right here, due to trig identities, is equivalent to 1. So we just move that over and this becomes 1. And since this whole thing is being divided by cosine, so it's the 1 being divided by cosine, and the 2 times sine of x times cosine is also being divided by cosine. So right here, 1 divided by cosine is right here, and that's equivalent to secant of x because of trig identities. And on this side, we have cosine of x is canceled out with cosine of x because it's being divided. So we're left with secant of x minus 2 sine of x. And that brings us back to what we first had. And so therefore, we prove that one side is equivalent to the other.